The moment of inertia of a uniform disk about the diameter is I. Its moment of inertia about an axis perpendicular to its plane and passing through a point on its rim is. So one disk is given. Consider this is the disk. Moment of inertia about the axis which is along the diameter is axis ke about moment of inertia I is given. Okay, and we know that if axis is passing through the center of mass and perpendicular to plane about this axis, the moment of inertia is mr square by 2, where r is the radius here. Now if axis is along the diameter, the moment of inertia is about this axis, the moment of inertia will be mr square by 4. Now here question is, we have to find out the moment of inertia if the axis is perpendicular to plane and passing through one of its rim, means this axis, this is the axis. Okay, this is the axis. इस axis के about हमें moment of inertia निकालना है. So here we can see that these two axes are parallel and this axis is passing through center of mass. Okay, so we can use here parallel axis theorem. Parallel axis theorem we can use here. And what is parallel axis theorem? Moment of inertia about this axis is, let's say, I dash. So I dash, which is equals to ICM plus md square. D is what? Distance between these two axes. Here it is radius r. So instead of d we can write here r square. So what is ICM? It is mr square by 2. But we want answer in terms of I. Now if I am comparing these two, if I am comparing first and this second, this is the moment of inertia about axis which is passing through center of mass. So from this I can write mr square, which is equals to 4 times I. And from this I can write mr square, which is equals to 2 times IC. So mr square is equals to 2 times IC. So instead of mr square I can write 2 times IC, which is equals to 4 times I. So moment of inertia if axis is passing through center of mass, it is 2 times I. So instead of this we can write 2 times I plus mr square. Okay, so instead of mr square we can write 4 times I. So this 2I plus 4 times I, it will give us 6 times I. So this is the moment of inertia about this axis. Okay, so correct answer is option C is correct here.